Hi, in this video, we will discuss the overall remark for the second order ODE. To solve the second order ODE problem, you must master the ability to classify the type of differential equation. For example, you know how to calculate the order, linearity, whether it's linear or non-linear, and then you know classify either is ODE or PDE. Lastly, you know how to classify the homogeneity, such as whether it's homogeneous or non-homogeneous ODE. Then you must master how to implement the second order ODE strategy to solve the homogeneous and non-homogeneous problem. So we have a second order linear homogeneous ODE here, where the right hand side is equal to 0. For this problem, we know the solution will be in the exponential format, and you can find the root m from the characteristic equation. Once you solve the characteristic equation, you can find the root m1 and m2. If m1 is not equal to m2, then in this case, the complementary solution can be obtained in this format, which is the c1 multiplied with exponential m1x plus c2 multiplied with exponential m2x. So you see a linear combination between the y1 solution and y2 solution. If m1 is equal to m2, then your y1 solution will be linearly dependent with the y2 solution, which is not good. So you need to perform the treatment by multiplying the second solution with the independent variable. By doing this, now the y1 and y2 solution are linearly independent. We continue with the non-homogeneous problem, where the right hand side function is not equal to 0 now. If your right hand side function is consists of exponential function, sine function, cos function, or the polynomial function, so in this case, we can use the method of undetermined coefficient to solve it. The solution to this problem is called the y total, or the total solution, is equal to the complementary solution plus the particular solution. The complementary solution can be obtained by let the right hand side equal to 0, and then you continue with the previous approach to obtain the complementary solution. Make sure you always solve the complementary solution first. Then the particular solution can be obtained based on the right hand side function here. So the exponential format here will be remain, and the polynomial function here will be written in the general format for the polynomial function with the same degree n. For example, if you have a constant 5, so the n degree is 0, therefore the general formula here is equal to 8 constant. If you have 5x, then the general formula here will be ax plus b. If you have 5x squared, then the general formula will become ax squared plus bx plus c. If you have exponential 5x on the right hand side function, then you need to propose the particular solution to be exponential 5x here also. Since the constant is 1 in this case, therefore we can propose the polynomial equal to constant a. If you have the right hand side function equal to sine 5x, then from the Euler formula, you know you can link the sine 5x to the exponential, where sine 5x is the imaginary part of the exponential I multiplied with the 5x. Then you can propose the particular solution equal to exponential I 5x, where the polynomial is equal to constant 1 here, therefore you can propose multiply with a here. So in simple, the particular solution is ae I 5x. And lastly, you can obtain the actual particular solution from the imaginary part of the yp solution. If we change the right hand side function to cos 5x, So in this case, cos phi x will be equal to real part of the exponential I phi x based on the Euler formula. So you can propose the particular solution equal to this, where the actual particular solution should be obtained from the real part of the YP solution. There is another alternative to propose the particular solution when you have the cosine function or the sine function on the right hand side function here. In this case, we can propose the possible particular solution to be in this trigonometric format. So you have a cos phi x plus b sin phi x. So this is another alternative when you have such right hand side function. So you must master the skill to propose the particular solution based on the right hand side function here. To validate the particular solution, we must check with the complementary solution and ensure both of them must be linearly independent to each other. For example, if you propose the particular solution to be this, and you found that this solution is same with y1 solution here. So we multiply independent variable to the particular solution and check with the complementary solution again. And now you see the particular solution is same with the y2 solution, and they are still linearly dependent. Therefore, you need to multiply x again to the yp solution. So now when you check the yp solution with the yc solution, all of them are linearly independent. Therefore, this solution is validated. So you have ex squared exponential phi x for the particular solution. If the m1 is not equal to m2 in this case, where your m1 is equal to 3, m2 is equal to 4, so you can see that these three solutions are linearly independent. Therefore, no treatment is needed. If we change the m2 to 5, and in this case, the y2 solution is same with the yp solution that you propose here. Therefore, you need to multiply x in order to obtain linearly independent solution. So when you check it again, now the yp solution are linearly independent with the complementary solution here. Therefore, you can proceed with this solution. Once you validate the particular solution, then you can proceed to differentiate it twice to obtain the yp prime and yp double prime. So after that, you substitute the yp prime and yp double prime inside this equation. Then by comparing the coefficient on the left hand side and right hand side, you can solve for the unknown a here. So with that, you success to obtain the solution for your yp. Substitute it inside this equation and as well as your complementary solution, then you can find the final total solution. Lastly, if your right hand side is composed of multiple functions, for example, you have polynomial function and sine function combined in summation format, then in this case, you can treat the function here to be R1 and this is your R2 function. So you need to propose your particular solution 1 based on the R1 and you need to propose the particular solution 2 based on the R2 here. In engineering application, the right hand side function here indicate the forcing function. So you have the forcing function 1 cause the first response and the forcing function 2 here will cause the second response here. So this response is called the steady state response. So if the question asks you to find the steady state response, then it will be equal to yp1 plus yp2 only, without the complementary solution. In this study, solving the homogeneous and non-homogeneous problem by using these two strategies will be the main focus. These two items are included for your extra information.